Hello, students. Good evening. How are you all doing? I hope you're all doing well. Welcome to another video. This is Catherine, your physics master teacher. Can you quickly let me know if I'm live? Am I live? Okay, now I think I am live. Yes, students, how are you all? Can you let me know if I'm visible and audible? I think I am. Hi, Sunita. Hi, Uday. Hi, Clueless Gamer. Hi, Prarthana Kulkarni. Quickly, all of you, quickly share the link to all your friends. Ask them to join. And I hope you have all watched the previous lecture because we are going to continue from Coulomb's law today. Yes. So have you all subscribed? Subscribe to the channel and liked the video. Please mark your attendance by liking the video. Okay. Yes. How are you all? Students, as I always say, if you're looking for offline classes, we have lots of offline centers. Okay, so you can just go to the video description and all the centers are there. You can just book a visit and visit any of our centers. And if you're from Karnataka, we have our Karnataka center now at JP Nagar where we have the best teachers. Okay, so if you go there, you'll meet lots of friends and probably all of you can go together to IITs or NITs or any college of your choice. Hello Praveen. Hello Sanjana. I am fine. How are you, Praveen? Hi, Sunny. Sunny. Okay, so let's not waste a lot of time. I think we have our class has people. Okay, let's start. So, last class, what did we learn? Quick recap. So, last class, we learned about electric charges and we also learned about the Coulomb's law, the very famous Coulomb's law. So, what was the Coulomb's law? So, if you have two charges, okay, and they're separated by a distance r, then the force experienced by the two charges is given by F is equal to K constant, Q1 and Q2 are it's the product of the charges divided by R square. This was our Coulomb's law. This we discussed in detail in last class. So I thought today we will start with a question. This is from a KCT past year paper. Okay, this is based on Coulomb's law. So we'll start with this, a quick recap and then move on to today's portions. Okay. Hi Suchitra. Hi Deepa. Okay, Deepa is Spurti. Hello Spurti. Why should I hate you, Spurti? What happened? Hello, Sanjana. Okay, so students, this is a question from previous year KCT. It has similar questions are there in NEET, JEE, everywhere. Okay, so if you are someone who's preparing for a competitive exam, quickly solve this with me. Okay, a point charge A of plus 10 coulomb and another point charge B of plus 20 coulomb are kept 1 meter apart. Okay, so what is happening? There is a charge of plus 10 microcoulomb, another charge of plus 20 microcoulomb. The distance between them is 1 meter. The electrostatic force on A due to B is F1 and the electrostatic force on B due to A is F2. Then, what is the relationship between F1 and F2? So, it's very easy. Students, please do smash the like button quickly. So, it's very easy. Okay, Praveen has already told me option B is the correct answer. Okay, let's see if option B is the correct answer. So, what is the force? What will F1 be? F1 will be K into Q1, Q2. Q1, Q2 will be 10 into 20 divided by 1 square. What should F2 be? F2 will also be K into Q1, Q2 divided by R square, which is 1, 2. So the only difference is in direction, isn't it? So both the charges will act in, if this is acting away, if this is acting in this direction, this is also acting in this direction. So you can see here, F will be equal to 1 by 4 pi epsilon naught. F will be equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. So the force on A and force on B both are equal. So both have the same value. If you do the math, you will get both are 1.8. The only thing is the directions are opposite. So the answer will be yes, option B. Because they will both act in opposite directions. They will both act away. Okay. So F1 will be in one direction, F2 will be in another direction. Hello, Sirsi. Welcome to Vedantu Karnataka channel. Sirsi is new to the channel. Everybody say hi to Sirsi. Okay. Welcome to the channel. Please invite your friends also to the channel. So Praveen has given me the right answer. So in Coulomb's law, that is one thing you need to know, students. The force acting on charge Q2 because of Q1 and Q1 because of Q2 will have the same magnitude because it's just the product of the charges divided by the distance between them. Okay. The only difference is going to be in the direction. Alright. That is a small quick revision from last class. So Sirsi, there was a video before this. So you have to watch that also. Okay, that's the first lesson. This is the second lesson. This is part 2. Okay, so today we are going to start with electric field. What is electric field? So you're all thinking, you've probably heard the word electric field for a long time. But what is electric field? See, imagine there is a very strict teacher. Okay, so there's a very strict teacher, and students are scared of the teacher. So what happens? Whenever the teacher is there, right in front of the teacher, nobody will talk in class, nobody will move in class, they will all be steady, they will all be very obedient because the teacher has an effect on all of those students. But the moment the teacher moves away, that means the moment the teacher moves away in such a way that the teacher cannot see the students, they will do whatever they want. Isn't it? So if they are in the presence of the teacher, they have a force acting on them from the teacher, which makes them sit quietly. But otherwise, they do whatever they want. Okay? So, okay. So, what is electric field is just like that. So, when there is a charge, okay, just like the teacher, imagine there is a charge. Around the charge, there is always a force acting, which is called the electric field. Now, as you move away from the charge, the effect of the force keeps on reducing. But if you're very close to the charge, the strength of the field will be greater. As you move away from the charge, the strength of the field keeps on varying. So that is electric field. So electric field is a region around any charged object where there is an electric force. Okay. So if I am a positive charge or a negative charge, I have a field around me. So if any other charge comes in the presence of that field, what happens? That charge will experience my field. Just like I said, if I am a very strict teacher and if any student comes in front of me, my effect will be there on that student because he's scared of me. But the moment he moves away from me, then I have no effect on him. Just like that, if you come close to a charge, the electric field is strong. As you move away from the charge, the electric field keeps on reducing. Okay? Yes. Yes, no. Yes, Praveen, it experiences a force. So, what is electric field now? It is a region around a charged object where it experiences a force, or where any other charge that comes in will experience a force. That is what is electric field. Okay. Now, why do you need electric field? Electric field helps us understand how a charge will be affected if it is in the presence of a field. So, if I am a charge and I have a field around me, if another charge comes, it's because of the field that I know the effect of this charge on my charge, on me. Okay. Now, if you place another charge, as I said, if this is one charge, this is another charge, since both of them are in the presence of each other's fields, they will either attract or repel, which means they will have a force acting on them. The force could be attractive or repulsive. So, if they're like charges, definitely repulsive. Unlike charges, they will attract. So, this is just like gravitational field. See how gravity acts on everything around you, even on you. Okay. So, electric field tells you how a charge will behave near another charge. Okay. Yes, electric field will tell you how a charge behaves in the presence of another charge. So, if all of this definition is correct, then what is electric field? So, electric field is basically the force experienced by another charge, which is F is equal to, E is equal to F by Q. Okay. Yes. So, if you have a charge Q, okay, let's say you have a charge Q, okay. Now this charge Q will have an electric field. Charge Q will have an electric field, okay. The charge Q has an electric field. Direction of the electric field is determined by the type of charge. Let's just assume Q is positive. So Q will have an electric field acting on it. Now, if another charge comes in the presence of Q, so let's say there's another positive charge in the presence of this big charge. Okay. So this small green charge will experience a force. And why does it experience a force? Because it is in the presence of another electric field. Okay. So basically, the electric field is equal to the force divided by the test positive charge, which is a small q. Force divided by the test positive charge. Why do I call it test positive charge? Because it is the positive charge that I am bringing to the presence of another charge. So Q is the charge. Q is the strict teacher, and then small q is a student coming in the presence of the strict teacher. So the student experiences a force because of the strict teacher. So the electric field is basically the force that this charge experiences divided by the value of the charge. Okay. So from that you get the formula E is equal to F by Q. Okay. So what is this Q? Q is the test charge. Okay. There's one charge that's already there. It has an electric field. You bring a test charge and that charge is Q. Is that clear all of you? So now what is electric field? Yes. So now what is electric field? It can also be called as the electric field is due to is because of a set of charges. A set or a system of charges. Electric field due to a set of charges is basically equal to the Coulomb force is equal to The Coulomb force. The Coulomb force on each unit test positive charge. Okay, so electric field is basically the Coulomb's force on each charge. So electric field is equal to F by Q. Okay, so whenever you have a charge Q, it produces an electric field E. The force is also going to be in the same direction. Okay, whenever there's a charge and it has an electric field E, the force is also going to be in the same direction. Now, what is a unit of electric field? The unit of electric field is Coulomb force per unit charge, which is basically Coulomb force per unit charge. Force per unit charge is Newton per Coulomb. Okay. How is it Newton per Coulomb? Because force is Newton, Coulomb is charge. So, what is happening on the chart? Okay. Yeah. Okay, students. So that is the force per unit charge is the unit of field. Now, it is a vector quantity. Isn't it a vector quantity? Because it has a direction, it has a magnitude as well. Okay. So, if you have, what is that? If you have a charge and this charge has an electric field. So, this electric field has a direction depending on what the charge is. If it's positive, the electric field will go outwards. If it's negative, the electric field will go inwards. That I'll explain. Okay. So, depending on what charge it is, it has the direction. It has a direction of electric field. Okay. So, the direction of electric field and the direction of force will be the same. I already explained that. If you have a force Q, if it has an electric field in this direction, it experiences a force also in the same direction. Okay. But it has a direction. That's the important part. Because it has a direction, it is going to be a vector quantity and it has two units. The first unit is Newton per Coulomb. There is also one more unit, volt per meter, but the unit that we are going to use in this chapter is mainly Newton per Coulomb. Okay. Yes. Now, next what we're going to find is the electric field due to a point charge. So how do you find out the value of electric field due to a point charge? So which means if you have a point charge, let's say the charge is Q. This has an electric field around it. So how do I find the value of electric field? We know that if there are two charges, what happens? They experience a force between each other which is given by the Coulomb's law. Now this is one single point charge. We're going to find out the electric field around it. The formula that we know is for force. Now we will find out electric field. Are you understanding, students? So in this chapter, the first formula that you learned regarding charges is the formula for force. Coulomb's law. F is equal to K Q1 Q2 by R square. Now we are going to write down that force first. That formula first. So what is Coulomb's law? According to Coulomb's law, F is equal to 1 by 4 pi epsilon naught. Instead of Q1, Q2, I will put it as capital Q and small q. Okay. Because here, that's what I wrote, right? The test charge was small q. Now, this can be written as KQQ by R square, which is force. Now, we also know that electric field is force by the test charge Q, which means force is electric field into the test charge Q. Okay. So now what I will do, I will combine these two. So when I combine these two, EQ has to be equal to KQK by R square because both stand for force. So now what happens? Q and Q cancels. So what is my formula now? E is equal to KQ by R square is my formula. From this, I can also write that E is proportional to Q by R square, which means E is proportional to Q and E is proportional to 1 by R square. Which means if you have two charges and the distance between them changes, the electric field also changes. Okay. Now, how can you represent that on a graph? So, what I can do is I take a graph. Okay. And let's say I have electric field E on the y-axis and I can put distance between the charges on the x-axis. So what happens? Since it's inversely proportional, it has to be a decreasing graph. And it's inversely proportional to the square. So shouldn't it be a graph that looks something like this? Yes. So electric field and distance varies inversely. Alright? If you have, so what is the scenario here? So if you have a charge Q, okay, and it is at a distance r with respect to a test charge Q, then the electric field is in this direction, force is also in this direction. Okay? Okay? Is this clear to all of you? Can you quickly let me know, students? Is this clear to all of you? Yes? So this is the value of electric field on a point charge. So neatly it's written here also. Okay? So this is electric field on a point charge in vector form. This is in scalar form. So students, don't be confused. Okay, so here this Q is equal to capital Q. Q naught is equal to small q for what I've written on the other side. Any notation is fine. Just because in my previous notation I used capital Q and small q, I'm using the same here. Is this fine? Yes. So now we know the force because of two charges. Now we know the electric field for a charge. Now let's do a quick question. Okay. A test charge of 2 microcoulomb experiences a force of 0.04 Newton in an electric field. Find the magnitude of electric field at that particular point. So let's write down the formula. F is equal to, electric field. So we don't need F from now on. Let's do E. E is equal to K into Q by R square is our formula. So what is the value of K? In the last class I taught you Coulomb's law. The constant K is 9 into 10 raised to 9 into Q. What is the value of Q? A test charge of 2 microcoulomb. Test charge of 2 microcoulomb. So you don't actually need to do this. You can just find out because you have the force also. Yeah. You don't need to substitute it in this formula, but you have the force also given. So what you can do, you can just write E is equal to F by Q. What is the value of force? 0.04 Newton is the value of force. Divided by 2 into 10 raised to minus 6. So when you do the math, you will get 2 into 10 raised to 4. So how can you do this easily? You just have to write this as 4 divided by 2 into 10 raised to minus 4. Okay, so you multiply it with 100 on the numerator and the denominator. Now what is 4 by 2? It is 2. So this will become 2 into 10 raised to 4. Alright. So the question only asked you to find out the value of electric field and they have given you charge as well as force. So direct substitution. Is this clear? Did you all get the answer? Is this clear, students? Okay. Now let's do one more question. Find the electric field at a point 0.5 meters away from a point charge of minus 2 microcoulomb. Okay, so we have to find out the electric field at a point 0.5 meters away from a point charge of minus 2 microcoulomb. So here charge Q is given to us, it's minus 2 microcoulomb, and the distance is given, it's 0.5 meters. So we have to find electric field. Now force is not given. Since force is not given, we have to use the formula kq by r square. We cannot use F by Q because force is not given. So let's use this formula. What is K? 9 into 10 raised to 9 into Q is minus 2 microcoulomb. You can just take it as 2 microcoulomb, because when you are finding electric field, you don't have to look at direction. You only have to take magnitudes. Okay. So minus 2 becomes 2. 2 into 10 raised to minus 6, the whole divided by R is 0.5 square. So this will now become what? 9 into 10 raised to 9 into 2 into 10 raised to minus 6 divided by 0.5 square. Okay, so 0.5 square will be 0.5 into 0.5, 0.25, right? So let's write it down. So this will be 9 into 2 divided by 0.25 into 10 raised to 9 minus 6. So this is going to be equal to 9 into 2. 2 by 0.25, I can write it as 9 into 200 by 25. Can I do that? Into 10 raised to 3. Okay. So 225 can easily cancel. This becomes 8. So 9 into 8 is 72. So this will be 72 into 10 raised to 3. Since it's electric field, the unit should be Newton per Coulomb. So I will write it as Newton per Coulomb. Very easy. Yes. Yes. Is this fine? Can you all let me know in the chat if this is fine? Is this clear to all of you? So this is another easy question. Let's look at another question. So students, these questions are all very important when it comes to competitive exams. Okay. And these are videos that are going to help you for KCT, NEET, as well as your PU. That's why we're doing questions also. Okay. An electric field of 200 Newton per Coulomb acts on a particle of charge 0.25 Coulomb and mass 500 gram. Find the acceleration of the particle. Okay, we have to find the acceleration of the particle. How do we find out the acceleration of the particle? You have electric field, you have charge. And then there's mass also. We have to find out the acceleration. Okay, let's do that. So first thing, let's find out the force. Since we have electric field given, we can use the formula E is equal to F by Q. So from this I will get force is equal to QE. So what will QE be? Q is how much? 0.25 into electric field is 200. So this is what? 200 into 0.25 will be 50 newtons. 25 into 2 and then zeros. Okay. So this will be 50 newtons. Now what I will do, I have to find out acceleration. For acceleration, I have to use Newton's second law, which you have all learned in first PU. What is Newton's second law? F is equal to m into A. So A is equal to F by m, which is 50 divided by 500 grams will be 500 divided by 1000 kilograms. So cancels. This becomes 50 divided by 0.5. 50 divided by 0.5 is what? 50 divided by half, which is 50 into 2, which is 100 meters per second square. Okay? How is it meters per second square? It's because it's acceleration. Acceleration is velocity by time. Velocity is meter per second divided by time is second. Meter. See, acceleration is velocity by time, which is meter per second by second, which is meter per second square. Okay? That is how I get the unit. I mean, you can get the unit with respect to other formulas also, but this is the easiest. Is this clear to you? Yes? No? Okay? So these are all some questions related to charges and force and electric field. Okay, we have a KCT question as well. Let's look at the question. A charged particle of mass m and charge q is released from rest in a uniform electric field E. Neglecting the effect of gravity, the kinetic energy of the charged particle after t seconds is. Okay, so what all is given? There is a charged particle, it has a mass of m, it has a charge of q, it is in a uniform electric field E. Okay, so there is no gravity. We have to find out the kinetic energy after t seconds is what we have to find out. Okay, so I have the solution here. All the steps are mentioned here. Okay, so it's just using our basic formulas. What is the first step? We know the force. What is the force? F is equal to QE, all of us know. Now what is A? A is F by M, which is basically QE by M. You all agree? Now what we will do is we have to find out kinetic energy. So in kinetic energy, the general formula for kinetic energy is half mv square. So m is a mass, but then velocity value we don't know. So what we're going to do is we're going to find out the value of velocity. How will I find out the value of velocity? I know acceleration, and I also know that there is a formula of kinematics called V is equal to U plus AT. Yes. Now, initially the charge is at rest. So the initial velocity is going to be 0. So V is equal to AT. So V is equal to QE by M into T. Okay. Now you just have to substitute V in the formula for kinetic energy. So what will you get? Kinetic energy is equal to half mv square. So it's going to be q square e square t square by m square. So m square and m will cancel. So you will get kinetic energy is equal to half q square e square t square by m. Which option is it? Half q square e square. I think it's going to be option C. Yes? Are you all getting option C? Can you quickly let me know in the chat? Are you getting option C? So this is a question that was repeated in the KCT 2022 year. Okay. So students, you might be wondering why she's doing KCT for teaching PU. No. See, whenever you obviously will appear for competitive exams after your PU, isn't it? So for that, conceptual clarity is very important. Only if you know your concepts well in physics, you can do questions, students. Only see if you just by heart the derivations that you like in your PU college, the teachers just tell you to learn the derivations and come. So if you just by heart the derivations and come, you are not going to be able to solve questions. So that is why we have these short lectures now to give you concepts. So we're not going to give you all the concepts in one class. So whatever concept we give you in one single class, we're doing questions also, so it's clear to you. The physics behind it is clear to you. Okay. Only then this is going to help you in your KCT preparations or whatever entrance exam you are preparing. Okay. Let me look at one more question. Okay. The magnitude of a point charge due to which electric field 30 centimeter away has a magnitude of 2 nanocoulombs, 2 newtons per coulomb will be. Okay. So the value of charge is given. The magnitude of electric field, the magnitude of electric field. The magnitude of electric field is given, the distance is given. We already know the constant. So what will we do? We will do the formula. So E is equal to KQ by R square is the formula for electric field. Yes. Now this is going to be equal to what? K is 9 into 10 raised to 9 into Q, the whole divided by 0.3. We know the value of E as well. E is 2 Newton, Newton per coulomb. So this will be 2 into 0.3, the whole divided by 9 into 10 raised to 9 is equal to Q. 0.3 square. 0.3 square. So now let's solve this. This is going to be equal to what? 0.3 square can be written as 200 into 9. Okay. I just multiply 2 into 0.3 square is 0.09. The whole divided by 9 into 10 raised to 9. So 2 into 0.09 is what? 2 nines are 18 and then 2 decimal places. So 0.18. The whole divided by 9 into 10 raised to 9. So this can be written as 18 divided by 900 into 10 raised to 9. So this is 2. So this is going to be equal to 1 by 2 into 10 raised to 11. This is the same as 2 into 10 raised to minus 11 coulombs. Students, you can do it however you want to. Okay? It's your choice. Sometimes some of you might just, convert 0.3 into 3 and then do it. It's all your choice. However you find it, you can do it that way. Okay? Okay. Next, what we're going to do is we're going to learn about the electric field due to a system of charges. Okay. So imagine there are multiple charges. There are so many charges. What do? We have to find out the electric field due to those multiple charges. And it is usually done by the vector addition of individual charges. Okay. So let's see how we do it. Imagine you have some charges. Okay. Let's say the charges are Q3, Q2, Q1, and so on. Okay. So these are the different charges. Okay. Now let's just imagine they are all different charges. So now the electric field. Okay. Let's say this one gives you an electric field of E1 in this direction. Okay. Now let's say Q2 gives you an electric field in this direction. E2. Can you see? E2. Now Q3 can give it in this direction. Now imagine you have Qn. Qn might be in this direction. En. So now the force or the electric field, the total electric field, last class we learned force. So the total electric field is going to be equal to E1 plus E2 plus E3 plus En. Okay. So if you have multiple electric fields, multiple charges and they all have electric fields, then the net electric field is given by the superpositioning or the vector sum of the fields due to all the charges together. Okay. So if you have 5 charges, the total electric field due to all the 5 charges is adding up all the 5 charges. Okay. So the net field is E1 plus E2 plus E3 and it just goes on like that. Alright. So the net electric field at one point. Okay. So the net electric field at one point is the vector sum of the electric fields produced by all the charges around it. Okay. Now let's do a question. Okay. Question time. Two spheres of electric charges plus 2 nanocoulomb and minus 8 nanocoulomb are placed at a distance d apart. Okay. So there's a sphere placed at 2 nanocoulomb. Another one at minus 8 nanocoulomb. It's placed at a distance d apart. They are allowed to touch each other. What is the new distance between them to get a repulsive force of same magnitude as before? Okay, so what we are going to do is, we are going to do it step by step. We'll solve it. Okay. Okay, we will solve it step by step. Hi, Singer Techie. Long time, Singer Techie. Hi, Lifestyle. Hello, ma'am. Doubt? Is that what you're saying? Lifestyle? Okay. So, do you understand the question? Now, what happens? They are allowed to touch each other. So, we have to find out what is the new distance between them to get a repulsive force. So, first, what we'll do, we will consider the initial force before touching. Okay. So, before they touch each other, what is the force between them? It's just 1 by 4 pi epsilon naught Q1, Q2 by, the distance is d, so I will just put it as d square. And what is the value? 1 by 4 pi epsilon naught, you take it as k. Q1 is 2, Q2 is 8. 2 into 8, distance is d square, which is 16k by d square. Okay. So before touching these individual charges, they have a force of 16k by d square. Now what happens? When they touch each other, now it is one conductor. So the total charge of this single one conductor is going to be equal to the sum, which is minus 8 plus 2, isn't it? So after touching, the charges redistribute the total charge. The total charge will be minus 8 plus 2, which is minus 6 nanocoulomb. Okay. So that is the total charge. Now there are two charges, two spheres coming together. The total charge is now minus 6 nanocoulomb. So 3 goes to one, 3 goes to the other. They redistribute, right? So now you have the two charges which have, okay, they're more closer together. They're more close together. So this has 3 nanocoulomb, this also has 3 nanocoulomb. Initially this had minus 8, this had 2. Okay. So this had 3, this had 3. Is this much clear? Now we will look at the next case. What happens next? After touching and separating. So they have both, initially they were here, they came together, now they have separated. Now when they are separated, what happens? What is the force? Force will be again k into Q1 is 3, Q2 is also 3. Divided by the new distance, I will take it as r square. So this is 9k by r square. So the force is something that is conserved, right? So the force before and after should be the same. So initially the two forces, the force was 16k by d square. Now after all the redistribution, the new force is 9k by r square. So now when you do the math, r square by d square is equal to 9 by 16. So from this you can get r by d is equal to 3 by 4 and r is 3 by 4 into d. Okay? Is that clear? You're welcome, Singer Techie. How was your KCT exam? Did you do well? Singer Techie was one of my students during my KCT. I used to take KCT classes before KCT exam. So Singer Techie used to be a regular student. Okay, students, is this question clear? So you have two charges. Okay, initially they're at a distance d. You find out the force. Now they're allowed to touch each other. So the total charge redistributes. Now what happens? They go back. So you're finding the final force. Okay. We will do one more question. So the concept is very clear in your head. Okay, even in your sleep, someone asks you about forces and charges and field, you should be able to answer. Okay, ABC is an equilateral triangle. So let's draw the equilateral triangle. Okay, ABC is an equilateral triangle. At each corner, there is a charge plus Q. Plus Q, plus Q, plus Q. Okay, at each corner, there is a charge plus Q. What will be the electric field intensity at the center O? Without any doubt, you should be able to tell me the answer by now. Okay. Let me just tell you. So because of this charge, let's say the electric field is in this direction. EB. Now because of this charge, the electric field is in this direction. So EC. Now because of A, the electric field is going to be in this direction. Okay. It's going to be in EA. Now all three are opposite in direction, isn't it? So the charges and the distances are totally same. The field is also going to be same. So they have symmetry and they will all cancel. So the net electric field is going to be equal to 0. Okay? Bye, Singer. The net electric field is going to be equal to 0. Okay. Yeah. So it is an equilateral triangle. They all have the charge plus Q, and at the center O, they will all have the same magnitude and they will all point in different directions. So what happens? The total electric field will be EA plus EB plus EC, which is 0. Okay? Okay. Okay, there's one more question. So there are 2-point charges. The first charge is A, the second charge is B. Charge A is plus 6 microcoulomb and charge B is minus 2 microcoulomb. They are held at a distance of 20 centimeter, which is 0.2 meters apart. Okay? 20 centimeters and it is 0.2 meters apart. So we have to find a point on the line AB where the electric field is 0. So we have to find a point. The point could be either here or here or here. It could be 1, 2 or 3. Okay, one of these places. These are the 3 main places on the line AB, right? It could be before A, or after B. Either one of this point will have an electric field which is 0. So we have to find that out. So let's just roughly think on where it could be. So here plus 6 coulomb will be acting in this direction. Okay. Now minus 2 coulomb will be acting in this direction, but it's going to be smaller. Okay. Now in the center, what happens? Plus 6 is going to be acting in this direction. Minus 2 is going to be acting in this direction. Yeah. Okay. Minus 2 is going to be acting in this direction. So anyways, it is not going to be 0. There are going to be charges here. There is going to be an effect here. So 2 is not going to be equal to 0. Okay. Next is at 3. At 3, what happens? Plus 6 will be acting in this direction. minus 2 will be acting in this direction. So here also there could be an effect. So let's take this to the solution and solve it. So what we are going to do is we are going to actually just copy paste this picture. What is happening? Okay, fine. I'll just draw it once again. So A, B, what are the values? Plus 6 and minus 2. Okay, distance is 0.2 meters. So what we're going to do is we're going to assume a point A. Okay, so from A is at x is equal to 0, B is at x is equal to 0.2. Okay, now we have to find out the point where the net electric field is going to be 0. So to the left, which is region 1, A is, okay, x is less than 0. To the right, x is 0, x 0.2. Now, if you go to B, here x is greater than 0.2. This is how we are going to define this. Now, let's analyze. Okay, so assume a point, sorry, excuse me, students. Sorry. Hi Ramesh, hi Preetu, hi Kavya. Okay, welcome. Yeah. So the electric field due to QA at point X is going to be equal to E is equal to KQA by X square. Now for B, what is it going to be equal to? Electric field at point B will be equal to KQB by, it's going to be 0.2 minus X the whole square. Okay. One way it's going to be X square. The other side it's going to be 0.2 minus X square. So, see, both the directions are in the same, both the fields are in the same direction, so they don't cancel out. Now, if you take it to the left of A, so here what happens? So, the field here, at this side, okay, if you take it to the left of A, here EA has to be equal to EB. This is going to be equal to KQ by X square times KQ by X plus 0.2 square. Okay, you just cross multiply, cancel out the common terms, cross multiply and do the math. It's just basic math. You will get, okay, let me just do that for you then. 6 into x plus 0.2 square is equal to 2x. So 6 into x square plus 0.4x plus 0.04 is equal to 2x square. Okay, and then you add all the terms inside, you will get 6x square plus 2.4x plus 0.24. 6 into 0.04 is 0.24 is equal to 2x square. So 6x square minus 2x square, it becomes 4x square plus 2.4x plus 0.24 is equal to 0. Now you divide the whole equation, you will get x square plus 0.6x plus 0.06 is equal to 0. Okay. Quadratic equation, you solve it, you will get two values. Okay, so there are two negative values. So the electric field is going to be 0 at which point? You get it at 12.7 centimeters. Okay. Okay. So people are getting to know each other in the chat. Ramesh is from Shivamoga. Preetu is from Devangari. Okay. All right, students. Let's continue. So the final answer is going to be x is minus 12.7 to the left of A. Okay. Next. Okay, this is just, let's just do this. Next, what I'm going to find out is, this is very important, students. This is very important when it comes to, questions. Did you all smash the like button? All of you smashed the like button. So let's consider a sphere. Okay. A sphere, this is just, a uniformly charged ring. Okay. This is a ring which has charges everywhere. The radius of the ring is r. Okay. This is a ring which has a radius r. Okay. Now there is a charge on one part which is called dq. Okay. I'm just taking one charge on the ring which is dq. Now I take a point at a distance x. Okay. So this is my point. Now I'm going to find out the electric field due to dq at this point. So how will the electric field be? It's going to be in this direction. Right. If it's positive, it's going to go outward. Now if I take another point dq here and look at the electric field due to the same point, it's going to have an electric field like this. So because of the two charges dq, there will be de, two different angles. So these de's are at an angle. So what I will do? I will take the horizontal component and vertical component for both. Okay. So if this angle is theta, okay, this angle is also theta, this angle is also theta, okay. So if this is theta, then this side will be de cos theta. This will be sin theta. Again here also this will be sin theta, this will be cos theta. Okay. So what happens to the vertical components? Vertical components cancel out since they are equal and opposite. Okay. So the vertical components cancel out since they are equal and opposite. Okay. So the x components will add up. Okay, so how many ever x components, how many ever charges I take, all the x components will add up. So now what will the total DE be? So DE x will be DE cos theta. The x component is cos theta, horizontal component is cos theta. So DEX will be, DE is what? The electric field. Electric field is what? K into Q divided by the distance. How much is the distance? This is the distance. So this distance is going to be equal to, let's take blue. So Pythagoras theorem, this is x, this is r. So this will be r square plus x square. So r square plus x square into cos theta. What will the value of cos theta be? Cos theta is going to be equal to x Adjacent side by hypotenuse. So adjacent side is x. Hypotenuse is r square plus x square. Cos theta. This will be square root. Yeah. Square root square. Okay. So this will be x by square root of r square plus x square. So now dEx is going to be equal to kq divided by r square plus x square. No square root and square cancels. X divided by square root of r square plus x square. Are you understanding this? Is it clear to you? So you have a sphere and then you take the two dE components. Okay. The y components cancel, x components add up, and then you find out the angle. Okay. Now what we will do? Now, if E is the net electric field. Okay. If E is the net electric field, then this is basically the sum of all x components. Isn't it? So E is going to be equal to the integral of dEx, which is going to be equal to the integral of what is the value? Kq divided by r square plus x square into x by square root of r square plus x square. Okay. Now what I will do, E is equal to, I'll take all the constants outside. K will be a constant, x is the distance, it's a constant, divided by r square plus x square into r square plus square root, this is 1 by 2. So 1 by 2 plus 1 will be r square plus x square, the whole raised to 1 plus 1 by 2 into integral of dq. So this is going to be equal to kx. Integral of dq is what? All the charges together will be q. Okay, dq is one charge. When you integrate it, you get all the charges. So kx q r square plus x square, the whole raised to 3 by 2. So as that the formula that I have here, E is equal to 1 by 4 pi epsilon 0 is k. Qx r square plus x square, the whole raised to 3 by 2. Okay. Yes. So here I have put only the important steps. So all the other steps are here. Okay. Is this clear to all of you? So this will also be theta. This is x. Yeah. Okay. Is this clear? Okay. Now moving on to the next topic, which is electric field lines due to a point charge. So what are the electric field lines due to point charge? So, from this chapter's beginning, I'm saying point charge, electric field lines. And now I'll show you how exactly it's going to be. So every time you have a positive point charge, you can see that the electric fields move out. Okay. So if you have a positive charge, electric fields actually move out like this. It continuously moves out. Okay. Now, if the electric field or the charge is negative, you can see the field lines move in. So that is why in all the questions previously, if it's always, whenever it's positive, you can see field lines moving out. Whenever it's negative, you can see the direction of electric field is in. Okay. Now what happens if you have two positive charges coming together? So you can see here, it's a beautiful, a very nice way. So if there's two positives, what happens? They have to repel. Positive, positive will repel. So when positive, positive repels, what happens? The electric fields move out like this. So there are no fields at the center, so they cannot attract. They repel. The same thing happens with negative. So when a negative and negative comes together, they also repel. But the difference is when positive, positive comes together, the field lines move out. When negative, negative comes, the field lines move in. Now what happens? Negative and a positive come. So from the positive, field lines will move out, but they will go in to the negative. See? See? They're going inside the negative. Okay? Okay? So from the positive, the field lines go into the negative. Alright? You can see from positive, field lines go out. From negative, field lines go in. So that is what happens. Okay? RXBTCC. Is that your name? Yeah. These notes will be uploaded on Telegram. Okay. You can join the Vedantu Karnataka Telegram channel. We will give you these notes. Okay. Are you from first PU or second PU? Okay. Now, when we look at some properties of these charges, we can see that the first one is for a positive charge, the field lines are radiating outward in all directions. Okay. Field lines are going out. And they show that direction a positive test charge would move away. In the outward direction, that's the direction in which the test charge would move. Now for a negative charge, field lines move in. So a positive test charge will be attracted to it. Okay? Do you understand that? Hi Ramesh. Now we will look at some properties of field lines. So field lines always start from the positive and they go in to the negative. This is the first property. Now, the number of field lines is proportional to the magnitude of the charge. So, for example, if this has a charge of 1 coulomb and it has 1, 2, 3, 4, 5, 6 field lines, then a charge of 2 coulombs will have 12 field lines. Okay? So, the number of field lines will depend on the magnitude of charge. So, if the charge has a very high magnitude, it will have a lot of field lines. If the charge is very small, like 0.1 coulomb and all, very few electric field lines. Okay? And then field lines never cross each other. See, one field line like this and another field line like this is not possible. You can see in all these pictures, the field lines are always no two field lines are touching each other. They're always going out properly. You can't see this field line going like this and the next field line going like this. No. The next field line won't go like this. No. Field lines never cross each other. They always, what happens? They always take their own path. They never intersect. Okay? Now, if there are closer field lines, it means stronger field, and weaker field lines, spread field lines, weaker. So, you can see in these pictures. Look at this picture. I'll explain it with respect to this picture. So, if the field lines are, see, you can see here what happens. The field lines are all very, very close together, which means around plus Q, the field is strong. Okay? Now, look at this part. Here field lines are a little more spaced but not as close as the central part. Now as away, you can see the field lines are separated more and more. Isn't it? Initially in the first charge, field lines are very close. Then field lines become more separated, more. The more the separation, the weaker the field. Do you understand that? The more the separation between the field lines, the weaker the field. So if field lines are very close together, that is where the electric field is the strongest. Okay? So electric field is strongest when field lines are close. The electric field is weak as you move away from the charge. Okay? So those are the key properties of electric field lines. So let's look at the key properties. We already looked at it. And then how do you get the direction of field? So if this is an electric field line, okay, at any point you take a tangent. So you get the direction of force at that point. Okay. So at any point, a tangent to the electric field gives you the direction of force. And then it always starts from positive, it goes into negative. When they're close together, they're strong. When they're far apart, they're weak. They can never cross each other and they are continuous. So an electric field line is not like this. They're continuous. Okay? And they're always perpendicular to the surface of any conductor. This we just discussed now. Okay? Now let's look at some questions. Yes. Okay, we can look at these questions. Which one of the following is true concerning electric field lines? First, they never cross each other. That is definitely true. They form closed loops. No, they are not going to form a loop. See, an electric field line doesn't do this. It just goes from positive to negative. It doesn't form a closed loop. Is it? If this is a positive and this is a negative, it moves from positive to negative, but it is not going to form a loop. Okay? So they do not form closed loops. They start and end on the same charge. No, they start at positive, they end at negative. They are parallel to the surface of the conductor. No, they are perpendicular to the surface of the conductor. Okay, so the answer is obviously A. They never cross. So this was also a KCT question. Okay. Okay. Next. Which of the following statements about electric field lines is incorrect? I think this is also a similar question, right? Electric field lines never cross is correct. They do not form closed loops is correct. Cannot be taken as continuous terms. Start from positive and end on negative. Which one is incorrect? Which one is incorrect? Yeah, so it is 3. Hi, Sunita. Now, next is a question. Okay. So this is a question based on the electric field lines. Question. Solution. Okay. Are you all enjoying the class till now? So students, those who have not watched the part 1 of this, you have to go watch that. Okay. Because in this class, I've used formulas from that lesson as well. We will have more exams, more parts. Oh, Naveen the crazy. Yeah. Good. Okay, Naveen wrote a good exam. But you didn't let me know in the comments. I was waiting for all your comments after, under those videos, but none of you commented. I remember you, Naveen. Okay. Yeah. I remember Naveen the crazy. Okay, question. The electric field lines on the left have twice the separation compared to those on the right. Okay. If the magnitude of the field at point A is V by 40, V volt per meter, what is the force on a 20 microcoulomb charge placed at a point B? So I don't think the figure is added here. Yeah, you did now. Yeah. I'm good. How are you? So here, okay, we can just look at this, the part where the electric field lines have twice the separation. Okay. So imagine you have a charge. Okay. You have a charge and the electric field has twice the separation. So the electric field is proportional to separation like this. So more the electric field, less the separation. As I said, if the electric fields are very close together, the separation is greater. If the electric fields are far apart, the separation is small. If the electric fields are far apart, separation is high. Yeah, electric field is weak. Yeah, I'm also confused now. So when the electric field is very strong, separation is small. Otherwise, it is different. So F is equal to Q by E is the force. So let's find out. Okay, for this I don't know. I don't have the figure. I think I haven't copy pasted it. So then I think we'll have to discuss this question in the next class with the figure. I can just tell you what we've done. So if electric field at point B is EB, then the field strength will become half. So it becomes EA by 2. Okay. And then you just have to find out the force. What is force? Charge into electric field. You find out the electric field using this formula and then you do charge into electric field. Okay. So the relationship that we know is when the spacing becomes double, electric field strength will become half. So that is why EB will be EA by 2. Why? Because the spacing has doubled. So what happens? The electric field strength should become half. Alright? That's all. It's a very simple concept that you apply here. Okay? Yes. So students, today we learned a lot of concepts. So you might be thinking the content, we've not learned a lot of concepts, but we've actually learned a lot of concepts and we've learned on how to apply those concepts. Okay? So, Naveen the crazy, I replied, I am doing very well. Okay? I hope you are fine too. How are you? What are your plans after your exam? Your exam went well, no? Hi, Monster Gang. The class is over. Why didn't you come early? Okay? So that's all for today. We will continue the series tomorrow. We'll discuss about electric potential and all of that. Okay? So please watch the video before this if you haven't. And students, if you're looking for offline classes, please do visit our JP Nagar Bengaluru office. Okay, book a visit and go. In the description box, you have a Google link to book a slot. You can book a slot so people can be there to greet you, treat you, tell you everything, your doubts and all of that. Okay. Okay. So if there's nothing else, shall we wind up today's class? So I'll see you all with another class tomorrow. So tomorrow 8 o'clock. Students, I want all of you to join. Okay. So please send the link to all your friends and tell them tomorrow 8 o'clock physics class is happening. Very important portion. Electric potential is happening. Okay. So you have to be there in class. Okay. All the best. I'll see you in the next class. Okay. Is there anything else you want to tell me?